Dear students, today let us learn to make a graphical representation of the weather data. In this lesson, you will be able to learn how to collect the weather data, how to read and understand a climograph and hyetograph, how to construct a climograph and hyetograph, and how to detect patterns and relationships between climate and human conditions. The weather, as you know, denotes the atmospheric phenomenon at a particular point of time, at a particular place. The climate, on the other hand, carries a much higher connotation both with respect to the length of time and extent of space. Weather represents the mean values of the atmospheric elements over a fairly wider territory and a far longer period of time, at least for a period of 30 to 50 years, spread over the entire North India or entire South India, etc. The weather of a place is created by the various combinations and proportions of interaction with various atmospheric elements. These atmospheric elements are temperature, air pressure, wind direction and its velocity, sky condition such as cloudiness, precipitation, humidity and visibility, etc. In order to understand the weather and climate of a region, we need to observe and measure the atmospheric conditions by recording the distribution of these weather elements by various methods using appropriate instruments. Some of the weather recording instruments are thermometer, barometer, wind vane, etc. Recently, there are advances in weather recording instruments. They are mostly digital in nature and they record automatically. Thermometer. Temperature is measured by means of thermometer. The unit of measurement of temperature is either centigrade or Fahrenheit. Thermometer is used for measuring the surface temperatures. India has adopted the decimal system since 1957 and the weather reports give temperature in Fahrenheit and centigrade degrees. All temperatures are measured in a well ventilated structure known as Stephenson's screen. You can see in the figure that the thermometers are mounted inside this screened box so that the thermometer remains under shade, free from the disturbances of sunshine which may raise the temperature. The kind of thermometers used for recording temperatures are two types: wet bulb and dry bulb thermometers, maximum and minimum thermometers. Wet bulb and dry bulb thermometers. These thermometers provide a means of measuring humidity. In the wet bulb thermometer, the bulb is kept wet by a piece of muslin and a wick that dips into a vessel of pure water. When the dry air touches the bulb, its energy is used in evaporation of water, which lowers its temperature. On the other hand, the dry bulb is kept uncovered, exposed to the air. Its readings are not influenced by water vapor and hence remains higher than those in the wet bulb thermometer. The drier the air, the greater will be the difference between the readings of the two thermometers. The greater the humidity in the air, the less will be the difference in their readings. When the difference is known, humidity can be calculated easily with the help of tables. The maximum and minimum thermometers. The maximum and minimum thermometers record maximum and minimum temperatures during the last 24 hours. The mean temperature for the day is obtained by taking average of the maximum and minimum temperatures. The mean monthly temperature denotes the average of the daily mean temperatures. The normal temperature for a particular day denotes the average of temperatures for this particular day recorded over many years. Similar connotation applies to the normal maximum temperature and normal minimum temperature for a particular day. The temperature variation with altitude varies throughout the year. Therefore, before plotting, all the temperatures are reduced to sea level. The weather and climatic data. The weather and climatic data is collected in the meteorological stations located in the respective countries. The weather data easily available to anyone on the internet, which is provided by the tourism companies or the weather departments or the agricultural departments of the respective places. When weather data is steadfastly gazed at columns and rows for a given station, and then if you read about the meager description of the weather data in the form of text, actually no intelligent and logical thought of comparison or contrast will emerge in the mind of the user of this kind of data. In this background, one of the greatest helps toward visualizing and understanding climatic data is the use of graphs and charts. Climatic diagrams are quite different from the weather maps. Climatic diagrams at first represent mean values depicting normal weather conditions. Secondly, they are more specific in the sense that they often deal with some particular aspect, whereas weather map is largely composite in nature. Separate climatic maps are generally prepared to present temperature, pressure, and rainfall data by means of isotherms, isobars, and isoheights. Besides, many types of graphs and diagrams are usefully employed to represent the climatic data. We will discuss some of the important methods of depicting climatic data in various diagrams here. Line graph, bar graph, combined line and bar graph, climograph, heighthograph. Line graph. Line graphs have been much more frequently used in illustrating different aspects of climate. These are simple and easy methods. Usually, amounts of temperature and humidity are shown along the y-axis as ordinates and time, that is months and years, along the y-x-axis. When a single element is shown on the graph with a curved line, it is called a simple line graph. On the other hand, when recourse is taken to a series of multiple line graphs for various stations on the same chart for the sake of comparison, it is called a polygraph. For instance, we can prepare a polygraph of mean monthly temperatures of the undernoted stations as given in the graph. Line graphs are the most useful means for showing trends in climate. Any single element, say rainfall or temperature, can be plotted on the graph to show variations over a long period of time. For example, we can show the variations in amounts of average annual rainfall in India over a period of 100 years by means of a trend curve. This figure shows the trend of the rainfall in India over a period of 100 years. For example, we can show the variations in amounts of average annual rainfall in India over a period of 100 years by means of a trend curve as shown in the figure. The bar graph or columnar diagrams. A simple bar diagram is constructed for an immediate comparison. Rainfall of a particular place can be represented by means of bars. Months are taken along the horizontal line and the perpendiculars are erected at both ends of the line. measuring rainfall in millimeters. Separate equi-base bars are erected on the horizontal line to represent rainfall for each of the 12 months. Sometimes the variations in amounts of annual rainfall can also be represented by means of simple column bar diagram. However, time series data are represented according to the sequencing of the time period. Combined line and bar graph. Often rainfall and temperature data of a particular station are shown by a combined line and bar graph. Mean monthly temperatures are shown by means of a curve and mean monthly rainfall by means of separate bars. Hence, climate graphs are a combination of a bar graph and a line graph as shown in the figure. The defect of this form of representation of climate data is that it may give an idea about the relationship between the temperature and rainfall. However, it is limited to explain anything more. Climograph. A climograph or a climogram is a diagram representing climatic variables like temperature and humidity. Climographs were developed to make it easier to characterize the climate of specific places. A climograph graphically depicts two different sets of information: average temperature and average relative humidity data for a location for 12 months. The monthly points are joined by a line. The shape and location of a line thus drawn indicates the nature of climate in terms of heat and humidity. The resultant 12-sided figure provides a general index of the climate of a particular station. Four authorities, Foster, Huntington, Legley and Reyes, agree on one fundamental point, that a climograph deals with rainfall and temperature. On the contrary, G. Taylor holds that a climograph should show relative humidity values in relation to wet bulb temperatures. The view of Taylor has gained more importance and it has become almost a conventional method of plotting a climograph. Taylor's climograph represents wet bulb temperatures as ordinates and relative humidity as abscissa. Each of the 12 points showing wet bulb temperatures and relative humidity for individual months is marked by initial letters of the month. The four corners northwest, northeast, southwest, southeast of the graph are marked as scorching, muggy, keen and raw characteristics respectively. They are very useful for comparative studies in climates because they provide general climatic index which can be understood at a glance. Scorch weather is the intense heat or what we refer for a burning sunny day. This weather condition occurs with high temperatures between 70 degrees to 80 degrees Fahrenheit and low relative humidity below 40%. Some extreme examples of weather can be referred to the temperate deserts like Sahara or Thar during the summer times. Muggy condition is generally when the temperature is high between 70 degrees to 80 degrees Fahrenheit and high relative humidity with over 70%. Such a condition is also referred as warm and humid weather. Some extreme examples of weather can be referred to the tropical rainforest regions. Keen condition represents a weather condition with intensely low temperature below 40 degrees Fahrenheit and low relative humidity below 40%. It can be also referred as cold and dry weather. Some extreme examples of weather can be referred to the subpolar deserts such as the Siberian deserts. Raw. The other extreme weather condition is raw, which represents intensely low temperature below 40 degrees Fahrenheit and high relative humidity with over 70%. Some extreme examples of weather can be referred to the polar regions, which is in the permafrost region. This figure shows the four different extreme conditions, the scorchy, muggy, keen and raw in the four corners of the figure. How to construct a climograph? To begin with, choose suitable scales to represent relative humidity along the x-axis and temperature along the y-axis. Locate the point on the coordinate to make the point January. Similarly, mark remaining 11 points February, March, April, May, etc. Join the points in order to obtain the 12-sided figure, which will be called the climograph for the respective regions. Here we have constructed the climograph of Bangalore and Gorakhpur. How to read the climograph? The four sides of the graph have extreme climatic conditions called as scorchy, muggy, raw and keen. They graphically represent qualitative human comfort levels with a given humidity and temperature condition. The analysis of the climograph for Gorakhpur shows that a muggy climate is present with more moisture and more temperature in the atmosphere. This gives an indication of more rainfall starting from May up till August. Besides this, the shape of the climograph indicates a wet bulb temperature and relative humidity in the atmosphere during different months of the year. The moisture content in the atmosphere during the pre-monsoon period and post-monsoon period shows health and agriculture situation in the surrounding areas. It can suggest the suitability of agricultural crops to be grown during this period. The climograph of Bangalore. Climograph of Bangalore shows that the city has a very pleasant climate throughout the year. Summers and winters are mild and there is a slight muggy conditions during the monsoon, that is during June to August. This again indicates crop suitability to the prevailing condition. Hyther graph. The Hyther graph was devised by Griffith Taylor. It is a graph, but the climograph as defined by Race, Foster and Huntington. In this case, each of the 12 monthly points is a temperature-rainfall ratio. Here, temperature is plotted along the vertical coordinate and rainfall along the horizontal coordinate. Their main use is to provide general climatic differences as they affect human activity, more particularly with reference to settlement. They are much superior to the above mentioned combined rainfall and temperature graphs because they help a quick understanding of the relationship between rainfall and temperature. Moreover, they are also well suited for comparative studies. Construction of Hyther graph. Choose suitable scales to represent rainfall along the x-axis and temperature along the y-axis. Draw the coordinates of 1 mm or 1 millimeter of rainfall and 26 degrees centigrade temperature to mark the point Jan. Similarly, mark the remaining 11 points Feb, March, April, May, etc. Join the points in order to obtain the 12-sided figure, which will be called the Hyther graph of Bangalore. Uses of Hyther graph. The two kinds of information are shown by Hyther graph are the average temperature and average precipitation of a particular place over a period of time. A Hyther graph for Bangalore shows higher precipitation in the summer months and the reverse for the winter months. This makes sense because it describes the weather patterns of such places as observed over hundreds of years. For example, September has higher temperatures at the same time that they have higher precipitation. Some months are hot and record huge amounts of precipitation each year. The converse of this can be seen at cold times, yet receive some amounts of precipitation generally through cyclones. Weather scientists use a Hyther graph to predict precipitation for various places. An examination of more than one climograph in time series can identify weather trends and climate change. Farmers may also consult a Hyther graph to plan for their planting strategies. It may be concluded that Hyther graph and climograph are some of the simplest methods but very practical ways of understanding the climatic scenarios, and we can make plans and take wise decisions whether you want to travel or you need to select the clothes you need to carry with you on the travel, or you want to select the type of crop to grow in your agricultural field. Thank you.